We end module 14 with a linear regression t-test for the slope. So now we actually want to formally determine if the association exists. We informally looked at it through the scatter plot and correlation coefficient. Now we're actually going to run the hypothesis test. The null hypothesis is that there is no relationship. We use the beta, this b, to stand for the slope. It's the Greek letter b. And so we're saying the slope equals 0, or there is no relationship between it, between those two values. And then the alternative all depends upon what you're testing, what your instincts are. Are we just testing for a negative association? Are we testing for positive, the beta is greater than 0, the slope, or not equal to 0, meaning that we have any association, there is someone, right, something. So that's a little weaker but essentially if we know it's less than or greater than, then we know if it's a positive or negative correlation. Now the procedure, step 2 is the linear regression t-test for slope, or we may call it the linear regression t-test, different names, so be aware. To calculate the values, we use ARDA-STAT, and we'll look at that. And then we'll come to a conclusion, right? If the p-value is less than alpha, we reject the null hypothesis, which means that we do have evidence, right? We would have evidence if we reject it. If we don't reject it, then there is not enough evidence to say that there's a linear relationship, and that's what that is. Now, when we run that test, right, in the ARDA-STAT will run the test for us, right? What does the conclusion tell us? Well, if we find there is evidence of a relationship, we can then for sure use that equation to make a prediction. So if there is a relationship, the p-value is less than alpha, then we use the regression line. Now, how do we make a prediction if there's no relationship? Now, this happens sometimes. There isn't, but I still want to make a prediction. We use the mean of our y values instead of plugging into the equation. That means the equation is useless. If there is nothing, and that's, again, the p-value is greater than alpha, we just use the mean of all the y values to do that. Now, here is that height and weight example that we talked about earlier in the previous videos or notes. We run a test. You have all the data here. You run the test. You get the t-test for slope. You get a test statistic, t-test for slope. You get a test statistic, p-value. It's 0.02. And because it's 0.02, it's less than alpha, we reject the null hypothesis. And so from there, we then say there is a positive correlation because we had the b greater than 0. So that's how we would do it, okay? Now, remember, the correlation coefficient gives us an estimate, right, for that. But it's until we run the test that we really do know what's happening. So back to ARDA-STAT in that linear regression. Let's look at that price and size one again. And again, I show you press linear regression, predicted values, but you could also then hit right here, show standard errors and p-values, and this is where you're going to look. You're going to look for the slope, the p-value for the slope, and that will then tell us whether to reject or not. We're looking to see the relation between the slope. Remember, on our test, we had beta, which is the slope. The intercept is a different test. So in this case, we're checking to see if the slope is equal to 0 or not, right? And so that's where you get the p-value using the ARDA-STAT. Click here, regression line, show standard errors. And so to end any test, we have the 5th step, which is reflect on practices. And so for linear regression, it's a little bit more complex. So what we want to do is, and we don't emphasize this too much in this class, you want to be aware of it, especially if you're moving on to other methods classes or psychology, sociology, other majors that need a second stats class, that we want to check some conditions, right? It's not always easy to check them. That's why it's a little bit, we need a more advanced technology and analysis. But we want to look at to see if the scatter plot's linear. We'll check that. We want to look at those residuals, and you have that residual plot over there we could analyze. Again, it involves a little bit more sophistication beyond this class, but you want to be aware that we want to analyze the residual plots. How far are the estimates from the actual values, the predicted from. So we want to make sure that there's like kind of equal distribution of error. You don't want to see like some wide error ranges, equal variances, and again, that's connected to, I'm sorry, the histogram, the residuals. When we look at the values, they should be normally distributed, like all kind of the same value, only some far away, and then the residual, they should be, the error value should be around the same for all your x values. There should be, again, it's a little bit harder to analyze, but you want to just be aware of them. The residual plots show no patterns in them. So that's, again, what you want to keep in mind. And like I said, how do we determine if there's a relationship, whether to predict? We talked about that a little bit. Again, we have those rules. If the p value is less than alpha, we use the equation. If it's not, we use the sample means. And that's what this last example shows us. We have a regression equation. Okay, assume the correlation is significant. Use this to predict the number of sit-ups a person can do who watches 6 hours of TV, right? We're assuming we have the equation, right? Sometimes it looks this kind of messed up. You have your slope and y-intercept, and then you would, because the p-value, we're assuming it's less than alpha, you can then make a prediction. So this is the hand calculations, but you would use technology in most cases because you have data.